Hello YouTube, RJ. Today we've got a big box on the bench that I'm very, very excited about. This is going to be the most expensive item in the lab, and it's very, very important that nobody rats me out to the wife and tells her what these things cost. I have spent years getting my wife to believe that all used meters cost between $100 and $200, and I really need her to keep believing that, because otherwise we won't be able to get anything new for the lab. So all of you keep your mouth shut. So let's get in. This is a very precise piece of equipment, and I hope it's truly in the shape it's was advertised, because it came a long way and it had a rough trip, and it's been almost a month in transit. So let's get her open. Oh, wait a minute. No, we can't do this. No. What was I thinking? An instrument of such precision, we cannot use such blunt force pieces of equipment to open. We need more precision involved. That's better. What was I thinking? A little bit like doing heart surgery with a jigsaw. Now, are we going to give it the thumbs up for packing? Well, I will say it looks a lot better than the packing on the last meter I purchased. We all remember the strawberry flat for the 34401. Or was that my 53131? I don't remember. So we at least have some foam. It looks like we got around it some inflatable baffling. That's good. Much bubble wrap. Very important. I think I'm going to give this one the 1 3/4 thumbs up. I think the packing was much more reasonable. I'll get this out of the way. Okay, now we're down to the bubble wrap. So let's continue. What is this? I didn't order a washing machine. Many layers. Many layers makes RJ happy. Never too much bubble wrap with my new toys. What is this? What do we see? It's red. That name. I know that name. You know that name. Ooh, mustn't have sticky on tops of our meters. Yes, it is a Keithley. What Keithley is it? Well, many of you know I was thinking about buying a Keithley 6500. Does that give us a hint? Well, maybe. But what do we have? Well, let me turn it around. We have a Keithley 7510, 7.5 digit multimeter, advertised to be in fantastic shape. Not a very old model by the serial number. And I was thinking of getting a 6500, but then I got to thinking, if I go used, I might be able to pull off a 7.5. And so that's what I've done. And so let me get set up here. We're going to check this thing out. Okay, I set up some little knickknacks to do a little testing with this meter. It's been put in its rightful place in the stack, and it's had the power plug connected. We're ready to do our first power up, but I had a moment of terror as I looked at the screen and realized this screen looks terrible. It's kind of scratched up and nasty. Oh, God. And then I looked and realized they've never removed the film off the screen. They've been using it with the film on the screen, whoever owned it before, they were using this on it, which I guess the touchscreen works with this on. And you can see how nasty and scraped up and scarred it is. I thought my screen was like that. I thought, oh no. Oh. But that's all it was. And so that leaves us with a perfectly spotless, beautiful screen underneath. So that's fantastic. So the first test we're going to do is turn it on, make sure the thing powers up. Doesn't have any errors or anything, because we don't know. I hear a noise. It looks like it's booting. Screen looks good. Wow. Look how fast it's giving readings. So, of course, this is just the first step. Now, by now, you've already started to question, what's the mason jar for? Are we canning fruit or testing a meter? Well, you don't just worry yourself right now about that one. We don't quite need that one yet. We'll just put him out of the way for the moment. We'll come back. First thing I think we should do is probably do a basic checkout. But before we do that, let me introduce you to my new little friends. I wanted new probes for my new meter, and everybody on the EV blog seems to just love these ProbeMaster probe tips. And so I ordered a set. And I haven't had a chance really to use them, but I will say the silicone wires are so nice. I ordered straight plugs because that was my preference, and I like the probe and the mushroom on the end. They've got a beautifully gold-plated, extremely sharp tip, and they even come with the little protector cones you screw on to shorten the tip. Beautiful piece of equipment. It's got a nice, like slightly rounded ergonomic shape. I'm very impressed so far. We'll see how they hold up. One thing I do need to do is test and see if they plug in well. Oh yeah. Oh yeah. So nice. No slop. Go in with just a little pressure, but nice. They're not going to just pull right out easy on you. I like them like that. Let's get to some important stuff. Let's hook up our meter here to our friend, the DMM-1 voltmeter tester. Now, I must admit, the accuracy and stability of this device does not meet the level of this meter, but it's what I have. This meter, I think, is going to be a reason that I'm going to create a new voltage standard voltmeter checker for Lynx. I think we're going to do that. So why don't we start out with 5 volts. Since we're on DC voltage started out right off the bat, I don't really know a lot. I've watched some people use these meters, but I don't think we need maybe that quick a reading. So let's stabilize them down a little bit. And let's use rail to get this thing zeroed down the best we can. And with that, let's see if we get 5 volts on this thing. 5.0094. 99495. I would say for our little inexpensive unit, I think that's pretty good. It's looking really good. To be thorough, we should turn the 34401 on, throw it in 6-digit mode, and just see what it thinks. So let's see, what did we end up with? 5.0094. 3 zeros and a 94, let's say. Let's null this rascal. 3 zeros and a 12. 13, let's say. 12, 13. So, not too bad. Not too bad. Now, I said I was going to potentially send the 34401 out for calibration. Well, obviously, that's not happening. The reason I held up on that is because I had this potentially on the way. So this, I'm going to spend the extra money. I'm going to send this meter out and have this meter calibrated. It looks like it's reading a DC voltage okay. How about we try resistance? Do our resistance. Let's do this. Let's short these plugs. Let's go over here and reel out that. Let's change our rate here. We don't need to read that fast. And we'll zero her out. And then we will plug her in and see if we have 5K. We have 4.99935 basically kilo ohms. I would say that's pretty darn good. I may so say myself. So it's pretty good on the resistor here. I think this meter is working properly. Let's go to, how about we try our current now? Okay, we're going to do DC current. You know, to move it from here to here. Let's again, let's slow her down a little bit. Don't need to be reading that fast. Settle in a minute. We'll, okay. Should get about 5 milliohms with this. I'm not. What is that? Plugged in the right place? No, I'm not. Might help. Let's try this again. Why don't we do this zeroed out again while we're plugged in there, and let's see if we get 5 milliamps. We get 4.994716 milliamps. I would say that's, so the best I can do with this is looking good. So I think we're doing good there. Let's go to, here is 90K here. Let's try 90K right there. 89.73. And let's jump all the way up into megs. These are not that precision. This is not for calibration. This is for just messing around with the circuit. Let's try 9 megs. And it reads 9.1812 megs. Okay, happy with that. Seems to be functional. That's really all I want to look at for the moment. We're going to get into something really neat here in a minute. Okay, let's try the capacitor. Let's hook up to a set of these. Again, not going to be super precision. Not what we're doing. That's not what it's about. See, capacitance. Okay, let's go over here and capacitance. Let's go over here and REL that out. And let's turn on a nanofarad. There's a nanofarad. Let me turn the filter on. Pretty close. It's bouncing 1 nanofarad there. Let's turn that off. Let's try 100 nanofarad. So that's 100. So I guess we had another 100. 0.199 microfarad, go another one. Now it's 300. Should be 400. Let's jump over the bigger blocks over here. What do we got? Or 1,000 nanofarad here. So 1,000 nanofarad. 1 microfarad. Another 1,000. There's 2. There's 3. Hey, looks like it's working perfect. All right. How about AC? Well, let me boot up my signal generator over here. We'll throw some AC in it and see if it looks like it's functioning right. Happy so far. So let's go back and let's do some AC voltage. And I shouldn't be putting anything out at all. So let's REL it. So we can get a little better than that. Well, of course, it was pretty low. All right, now. Okay, so I've got it set to 120 hertz at 5 volts RMS. So let's turn the channel on and see what we see. Say pretty darn close to 5 volts. 4.99765 RMS. And we should be able to go to amplitude. And I should be able to change that. There we're at 6. Yep. 7. Go down. There's 1. Looking good. I don't have a lot more to test with except for one thing. I want to see just how sensitive this thing is. So we're going to do a really interesting little experiment. It's not a calibration. It's not a check. It's just having fun. So give me a minute to set it up. I'll get the mason jar back out. All right. What we've got here is we've got a K-type thermocoupler connected to the 7510. We're looking at temperature. and we're looking at pretty fine measurement of temperature with it. And you can see the graph is running along there on the bottom. And the thermocouple is in a mason jar of water that's been sitting in the room for hours to get to room temperature the best we can. And so I'm going to go ahead and blow up the graph some here. Scan it, scale it out. And it looks like it's diving for the end of the world, but the truth is you're looking at such a small little window there that it makes it look that way. It is still cooling down. The air conditioner is running, so that may have some effect. But what I want to do is show you how sensitive this thing can be. This is just ordinary LED flashlight, okay? Kind of zoom the beam in a little there. And I'm going to take this flashlight and I'm going to shine this flashlight on this jar at the thermocouple in the middle of the water there. It's just floating in the middle of this water, big thermal mass. You wouldn't think this light could warm that water very much, but the energy from this light, these photons on that thermocouple, this meter will sense it, and I don't even have it on its highest sensitivity. So watch what happens as soon as I put it on there. Boom, look at that. Heading for the hills, my man. Nothing but a flashlight. Now, if you're wondering if there's some magic going on, watch this. Take the light away immediately, and immediately, I haven't warmed the thermocoupler in the water all up to the point that now it's got to slowly get rid of the heat. It reacts fairly quickly because you're talking direct energy delivery to that thermocouple. It is filling this light. This light doesn't put a lot of heat out. It's not a hot light. It's LED, but you can see it coming back down. I can turn around and do it again. Stabilize out a little bit. Let's hit it with it again. Immediately responds. Now I'm doing it up pretty close to the jar. What's interesting is if I get off of it, notice immediately it responds and starts coming down. To me, that's just amazing that I can do that. So sensitive. The next stage of this meter is it's going to the cowl shop. I'm hoping to be able to do a video on that where maybe we can talk to the guys at the cowl shop. Thanks for hanging out and checking out my new meter. I'm very excited about it. It's going to be a real value in the shop. Do me a favor, if you haven't subscribed, hit the subscribe button. I really need it. And like this video if you liked it. It helps me greatly. Thanks a lot, and I hope to see you in the next video.